So within this lesson, we're going to talk about solving systems by substitution as well as elimination. So for substitution, we're plugging something in that is equivalent. So our steps are over here off to the side, but they're also up at the top. So we need to solve one equation for one variable, like x. Doesn't matter, x or y. In this first example, we actually have them both set equal to y, so we're covered there. We just need at least one. Then we're going to substitute that found expression into the other equation. And then we will solve for the variable, and we'll actually plug it back in to find the second. So we should have an x and a y. So notice that this equals y. So we're going to plug this in for this y. So instead of this y, I'm going to go ahead and write out the second equation here. Instead of that y, I'm plugging this in because it equals y. Or technically, since they both equal y, they can equal each other. But I want you to see it as a substitution kind of plugging in thing. So now we're going to solve. I'm going to get rid of the smaller variable. So 2x plus 3x is 5x minus 1 equals 4. And then we're going to add 1, and 5x equals 5. When we divide by 5, we get x equals 1. So that's part of our answer. That is our x variable. X comes first in our ordered pair, y is going to come second. So we need to figure out what y is. So y equals, it doesn't matter which equation you use up at the top. I'm going to just pick that first one, but I'm going to now replace the x with what I know x is. X is 1. So I'm going to replace it and put a 1 in for x. And I'm going to solve. 2 times 1 is 2, and 2 minus 1 is 1. So now I know what y is, and my answer is 1, 1. So if you want to try the second one on your own, go for it. We're substituting in. Now in this one, there is no variable isolated. So look for a single variable. I see the y. Could I get that alone? Yes, by adding 2x to both sides. And when I add 2x to both sides, I get y equals 2x minus 3. Now I have a y isolated, and I can replace the y with 2x minus 3 in the second equation. So when we write it out, 4x plus 2, we're going to leave a spot to replace the y. And I always think of it kind of like basketball. So this player, y, 2x minus 3, is going to sub in the game and replace the y that's in this equation 4x plus 2y. So we're replacing it. We're plugging it in because it is equivalent to y. It can play the same position. So now we want to solve. Now in this case, we're going to distribute because we have a coefficient in front, and we have 4x plus 4x minus 6 equals 12. When we have the same variable on the same side, you can combine those like terms, just add them together. And then we're going to add 6. 8x equals 18. Now this one's not pretty, and you can put it as a decimal or you can leave it as a fraction. I would just go ahead and do a decimal if it's one that stops, which this one does, because it's easier to plug it back in. So x equals 2.25 or 9/4. And then we're going to plug it back in. You won't really get a whole lot of ones that are not pretty, but occasionally. So just make sure that you plug them back in if you're not sure if that's correct. So it doesn't matter which equation you use, but I'm going to write out the top one, and then I'm going to replace the value that I know, which in this case is the x. So I'm going to replace the x with the 2.25, and then I'm going to solve. So we have negative 2 times 2.25 should be negative 4.5. There we go. And we're going to add that 4.5 to both sides. So y is equal to positive 1.5. Fixing my little error there. Now you can go ahead and write those as fractions if you want to. This would be 9/4 and this would be 3/2, but you can do decimals if that makes a little more sense to you. All right, go ahead and try number 3 on your own. Isolate maybe the x or the y here or the y here, and then substitute it into the second equation, and then solve for x and y. So go ahead and try that. If you're still a little unsure, I went ahead and got the y isolated just by subtracting x. So I had y equals negative x plus 3, and I substituted this in for the y here. So if that gives you a starting point, go ahead and go from there. All right, double check your answer that you got 3 for x and 0 for y. We're going to take a look next at elimination. Elimination is probably my favorite because we're getting rid of stuff. So the goal is to stack your x's and your y's on the same side and then your single numbers here on the other side, and to get the x's or the y's to be the same number but opposite, one positive, one negative, so that they add up to 0 and cancel. So we're kind of adding vertically here. So negative 3y, positive 3y ends up canceling. We just add our x's, add our numbers, solve, and then we can plug it back in. So let's take a look here. Well, this one's already actually set up to cancel 2x and negative 2x. That's going to cancel. So now we're going to add our y's. 3 and 9, that's going to make 11y. Nope, that's not going to make 11y. I can add 12y. There we go. And then 11 and 1, there's a 12 there. So now we're going to divide by 12, and y is equal to 1. So we know that that is our y value, and we can find x by plugging 1 for y back into either one of these equations. I'm just going to take the top one, it doesn't matter which one, and instead of y, I'm going to plug in the number 1. So here I plugged in, instead of 3y, put 3 and then times 1, which 3 times 1 is just 3. And now I'm going to subtract that from both sides. 2x is equal to 8. And then we're going to divide both sides. And that is going to give me x is 4. So 4, 1 is my answer. If you want to try the next one, you can. It's actually already set up with the y's to cancel, but it will give you a decimal, or you can leave it as a fraction, but just know that. Go ahead and try it. Sometimes helps to put the 1 in front of the x because it is a 1x. That makes 4x, and that equals negative 8. And then when we solve, x is equal to negative 2. And then when we plug that back in, again, it doesn't matter which one you use. Let's do 3 times negative 2 plus 4y equals 0. That's negative 6. And we're going to add 6. And 4y is equal to 6 when we divide by 4. That's when we get either 3/2 or 1.5. It doesn't matter if you write it as a fraction or a decimal. Okay, a couple more to try. I'm going to do one more with you, and then I'll just kind of show you what number 4 would look like. And then we're going to jump down to 2 special cases when things cancel out. So let's take a look at this one when we have nothing that's lining up. Well, this is a negative 5. Could I get this to become a positive 5 so that those would cancel? Yeah, I could multiply this by a negative 5 to get that to cancel. So I distribute it to each term when I need to change it. So that gives me negative 25x, that gives me positive 5y, and then that gives me negative 95. I'm going to go ahead and rewrite the top equation just right next to it because I'm going to be eliminating So now I have them kind of vertically together. So here's where it cancels. That's what I did to make them cancel. I made it positive 5. It was already, I kept the negative 5y. That didn't change, but this became positive 5y so that those would cancel. Now I add my x's, negative 22x, add my numbers there. That's negative 88. Divide, and here is x at 4. So plugging 4 back in, I'm going to get 3 times 4 minus 5y equals 7. So that's 12. And then I'm going to subtract 12. Lots of solving here. And then we're going to divide by negative 5, which is going to give me 1. Okay, so try number 4. I'll go ahead and post the answer here so you can at least kind of see it and check yours, but definitely try it. What would you need to multiply? You're going to actually need to multiply both equations here by a number to get one positive, one negative. Look, these are already positive and negative, so you could multiply this by 5 and this by 3, or you can multiply this by 5 and this by negative 2, kind of your choice. But look at that, try it, and then check your work. So either way, you should get the answer 9 for x and negative 4 for y, but I went ahead and did the 5, multiplied the top equation by 5, multiplied the bottom equation by negative 2. Make sure that you're multiplying each term, and then that would change it to be these two equations that are equivalent, and then your x's cancel. But you could also multiply to get your y's to cancel. You have kind of a choice there. All right, what happens here? I'm going to use elimination because it's a little bit easier, because this is, could just multiply this by negative 5. So that gives me negative 5x, negative 5y, and negative 30. So notice this cancels, this cancels, this cancels. That's 0 equals 0, which is true. And when something is true, it's all real numbers that would work as an answer. So everything basically is going to work. Then on this next one, I'm going to go ahead and multiply this by 2 because we have a 3 and a negative 6, and so we just need to multiply that by 2 to get it to become a positive 6. So that's positive 6, that's negative 2y, and then that's a 10. So looking at these two equations, that cancels, so this is 0 on the left, but this is 21. That is false, which means no solutions are going to work. So we can have some unique cases, and that's what these two are showing you when things cancel. Now, if you get x equals 0 or y equals 0, that's not a special case. That's an answer. And when you get that, you plug it back in. Don't stop. It is not a special case, okay? That's an answer. It's 0 is your x or your y. This is when you have no x or y. No x or y, okay?